Bismillahirrahmanirrahim. Assalamu alaikum. The title of our project is Real-Time Image-Based Tracking. I am Lisa Rafiq and my group members are Muhammad Awais and Muhammad Jashan Masood. This project was supervised by engineer Mohammed Sagar Rawan and the industrial supervisor was Dr. Bashir. Real-time image-based tracking. Nowadays, actually, we know that the security sensitive areas have been using video surveillance norms. Recent years have also shown a noticeable rise in the number of incidents with drones related to both civilian and military installations. So, and with drone detection, most often relies on professional equipment, which is too expensive. So, there was a need for drone detection system that could work on low performance hardware. The problem statement of our project was object tracking without high speed image processing are not efficient. Basically what we are doing is we are detecting a drone and for that there were many challenges. Few of them have been mentioned. High variation among objects of same type, changes in appearance, illumination, viewpoint changes, scale variation, deformation, background clutter, and differentiating between bird and the drone. To overcome these challenges, we came up with the solution of using YOLO V4, which is for convolutional neural network based. To provide real-time object detection, it is very popular because of its speed and accuracy. This is the block diagram of our system. Basically, an input image is given to the respective system, which goes to the YOLO model, and then after that, the drone is detected. To produce this YOLO model for drone, we have trained our own data set. For that, we use a tool labeled image, in which we have hand annotated each picture, each image, and converted it to YOLO format. Because to establish the drone detection system, stages were firstly to collect the data, after that annotation was done, and then training, and lastly the testing to test the accuracy. So this was the result of our own data set that we of our project. Basically, YOLO V3 algorithm has been implemented and tested with drawn images from our own custom dataset. We have achieved 87% of accuracy and it has almost matched the theoretical calculation of our own. This is the hardware of our project. It's a revolving structure that has two movements, pitch and yaw movement, and two motors are responsible for this movement. The camera is positioned on the top, which is movable, and enclosure to detect the object, which is connected to the system. Arduino is used to rotate the motors according to the coordinates coming from Python script to Arduino serially. L298D motor driver IC is used to drive the motors and the battery is used to power up the motors. This is the circuit of our project. The two motors are responsible for the movement of the turret, the Arduino and the L298D motor driver IC. This is the external, internal and the motor placement of our project. YOLO V3 algorithm has been implemented and tested with drawn images from our own custom dataset and some random drawn images from internet. In view of existing threat of low altitude UAVs, we use YOLO V3 to detect the drone. The real-time object detection and tracking uses sequence of image processing algorithms, which is helpful for the application that needs real-time response, and it is useful for military purpose as well as for general privacy. Thank you.